Good morning. My name is John Brown, and in New Mexico I have been working fairly diligently on deploying a spread spectrum-based wireless internet access. Mostly fueled because I'm getting fed up with dealing with my telco and how long it takes for them to get a loop installed is pretty insane. If you want to send me email, there's my email address. If you put me on a mailing list I don't like, I'll come and hunt you down and shoot you. Remember, I live in New Mexico. It's legal to carry guns. Basically, I hate overhead, so I will have some stuff up here just as more of a notes for me and sort of track along, and then I'll try to fill in as much as I can with verbiage. Overview, why do we want to do wireless, types of technology, installation, equipment, costs, stuff like that, and the most important part, the operational concerns at the end. See, I did that so that you would stay here and not leave before you got to the real good stuff. Why wireless? We picked wireless infrastructure and started rolling towards that because it gives us better control of our network. It allows us to control our network end to end a little bit better. Removes the telco from the picture, and allows us to increase our revenues. Instead of having a customer have to spend $200 or $300 for a local loop plus our ISP access charges, the cost of a CSU, DSU, and a router, and all of that, we can get rid of a lot of that money going elsewhere and put those funds more into our coffers. And show of hands, how many of you are in the internet business to make money? Okay, good. Install increases our revenues, and one of the reasons is because we can get an install up and running typically in 5 days, which means I can start billing my customer sooner, which means I'm starting to get the revenue from that customer, as opposed to selling a circuit, waiting for US West, I said the telco, darn. Waiting for the carrier to install my loop 30 days later and then start billing the customer. I can start billing the customer immediately. Overall, I think it's cheaper bandwidth because once I buy the equipment, it's mine. I don't have recurring expense off of it. As Eric talked about, there is the unlicensed technology, and there's also licensed technology. We are using unlicensed spread spectrum in what is technically known as the ISM band, the Instrumentation, Scientific, and Medical Frequency Band, 2.4 gigahertz range. The nice thing is that we don't have to involve the FCC in our business at that level. There are other frequencies available. You have the 900 megahertz and you have the 5.56 stuff coming. Spread spectrum comes in two flavors, direct sequence and frequency hopping. It's really important that you know which piece of type of technology you're going to use in your deployment. Are you going to use frequency hopping, or are you going to use direct sequence? More importantly, are you using one and somebody else using the other? And for example, we have a link that's up, well, it's down right now because I'm getting dumped on by frequency hopping. So let me get a show of hands, see if I need to spend a little time on this, and I think if I do, it's worth it. How many of you understand the difference between frequency hopping and direct sequence? Okay. I'll spend just a couple seconds on it. Basically, frequency hopping changes frequency about 50 times a second, and it goes over about 79 or so channels in this 2.4 gigahertz range. And the intention is that I'm going to land on a channel band. I'm going to have a lot of high energy there, but a narrow frequency band, about a megahertz. Then I'm going to hop off and I'm going to come over to another one. And we keep bouncing around. And every time we bounce around to a different frequency, we're making sure that we have at least, I believe, 6 megahertz space between the last channel and the channel I'm on now. Now, the benefit of frequency hopping is that you can have interference, like Stewart's microwave, for example. Could be operating on one frequency, and the frequency hopping comes in, sees that that area is kind of noisy and bad, hops out, goes elsewhere. So frequency hopping is more robust as far as getting nailed frequency-wise or noise in the spectrum. The problem with frequency hopping is that you don't get the bandwidth through there. You don't get the bits through there. You're not going to see a frequency hopping, at least that I've seen so far, get you much past 2 or 3 megabits per second. And don't forget, that's raw bits. That's If you want to look at your useful overhead, you've got to put the wireless packet overhead in there and the IP frame and all that stuff and bury that all in, and you'll start to see what your useful is. Whereas direct sequence takes a channel and just scans right in that channel area and uses that particular channel range and stays there. The downside to direct sequence is if you have something that's creating interference in the direct sequence channel area that you've selected, the way you solve it is you go reprogram the box to go to a different channel, and you use that different channel area. Okay. But the big benefit of direct sequence is higher bandwidth, and in fact you can get better distance out of it. Okay. We are using direct sequence. If you're using any of the AeroNet 11 megabit cards that I've loaned out to a few people that I'm hauling up here now, or if you were at NANOG 11 and you used some of the AeroNet stuff, that was all direct sequence. I believe the 802.11 stuff that's here being used is also all direct sequence, whereas some of the old roamabout stuff is more frequency hop. Okay? I'm not going to spend a lot of time on license other than to say it's expensive, requires permits. Two words that immediately get me to move somewhere else. Talk a little bit about installation. Obviously you have to have at least 2 or more radios. Antennas, and that depends on the type of installation. Now there are technical operational concerns that come into antenna selection, and there is layer 8 issues that come into antenna selection. People hate antennas coming up on top of buildings. People hate antenna towers going up. And so you have to be concerned about how you do that install. If you're putting an antenna on top of a building, they're going to not want it to be seen. Some of them don't care if you can see it from one rooftop to another. We've worked with some property managers where they don't want it to be seen from one rooftop or another, and they don't want it seen from the ground at all. They want the thing completely hidden. They want you to paint it the same color of the building, et cetera, et cetera, et cetera. So you have to be careful about what kind of paint you use and how you go about doing the install while still having an antenna that's operational. Now, the other thing that you have to be concerned about, what we've found with dealing with property management companies, is you say, well, we're going to put a spread spectrum wireless microwave-ish kind of a thing up on this building to do internet access. The first thing that comes in that property manager's mind is this 800-pound dish with this big, huge radome in front of it and a triax tower, okay, and 6-inch diameter guy wires going out. That's not the case. A 24 dBi grid dish weighs about 5 to 10 pounds. It's made out of die-cast lightweight aluminum. It's really easy. You just pick the thing up, flims it around, and away you go. So there's this mindset that you have to work on getting over with the property management people that this is not some big, huge, you know, FAA, Navy, Air Force search radar dome that's going up on top of the building. Okay? You need to think about how you're going to mount it. A skid. Skids, you can buy them or you can build them. I build my skids out of Unistrut. It's easy, it's relatively cheap, and I can make them any size I want by just cutting the lengths of the pipe. And basically all a skid is a square box, probably 4 to 6 feet square or bigger, depending on how much surface area you want, and then a couple of cross members in the center, the pole, and then diagonals up to support the pole. And then your pole goes up, and there you are. So that's a skid. The thing you have to worry about with skids, though, is that most buildings that are flat roof have an equal load rooftop on them, which means they seal the roof with a rubber layer, and they throw gravel on it. Well, they don't want your metal skid rubbing on that rubber because it's going to cut a hole in it. And then the roof's going to leak, and then they're going to be upset, and you're going to have to come and fix it, and the whole thing snowballs. So when you put a skid up, make sure you get a nice thick rubber pad, separate the rock away, put the pad down, put the skid on top of the pad, put the rocks back, and then load it up with some cinder block or sandbags to give it a weight balance. You can build a skid a lot cheaper than you can go buy a skid. Most of the wireless stuff out there, they're charging an awful lot of money because they're really proud of their products. But you can find this stuff, if you buy the raw materials, you can find and build it pretty cheaply. We'll talk a little bit more about that. You want to use coax cable, usually 50 ohms. I like using LMR 400 or LMR 600 type cable. Belden has a new cable out. I don't know the part number yet, but it's specifically designed for 2.4 gigahertz operations. You want to treat this cable just like you would fiber. So you're going to roll it up in a little knot, make it really tight 90-degree bends and stuff like that. Please don't. You want to keep the cable nice, gentle sweeps. You don't want to crank the foam of the insulation in there. You want to keep the cable clean. And you want to tie the cable off. One of the things in FCC Part 15 for this unlicensed stuff is they take the TNC type connector and they sort of break it. They change the gender of the center. And so it's called a reverse polarity. So if you go to your local electronics supply shop, and Radio Shack does not carry these, okay? If you go to your local electronics supply shop and you want to buy the TNC connectors, you want to get RP TNCs, reverse polarity TNCs. Amphenol makes them. If you need the amp part number, I couldn't find it on my laptop when I was doing the presentation, but I can get you the amp part number. Send me an email and I'll post you the amp part number. Typically the antennas are an N connector or I think, yeah, an N connector, and you can get those anywhere. The reason they have this reverse polarity connector is so that it's not real easy for Joe off the street to go and start slapping stuff together and hooking it up and mismatch things, because the FCC wants this unlicensed spectrum stuff to be certified with an antenna, with a cable type, and a radio, all done by the manufacturer. They don't want to, they're trying to figure out a way of avoiding a lot of third-party interjection there. Well, guess what? It's failed. We got tons of third-party parts out there. You also want to do crimp and solder connectors. If you go buy a cable, typically most of the pre-made cables are crimp only. Please take the time, roll back the years to good old thin net and thick net Ethernet. Instead of just doing crimp connectors, solder the stuff. It'll make a better connector. This is an outdoor installation, typically. You've got wind loads on it. You've got tension on the cable sometimes. You've got a lot of weather stuff. You don't want just a crimp connector. So really look at soldering it. Do a site survey. One of the things that will save you lots and lots of hours of frustration is to make sure that, in fact, you have close to or good line of sight, or LOS, to your installation. I use a combination of a handheld GPS and Microsoft Maps or Microsoft Streets 98 software on my laptop, and I take that information and I plot out my points. So here's a customer point. Here I am. I'm standing on the roof. I've got my handheld GPS plugged into the serial port of my laptop. Microsoft Maps up. Boom, there I am. I drop a pin, push pin there, and I draw a line to where the nearest radio tower is that I have. And when I get my distance there, I can track across it and see the heading, and I can then look out with a spotting scope and look on top of other rooftops. You want to have a good spotting scope, and you want to make sure that you find the other end, that you see the far end. You may not need to see the antenna because your antennas are going to be kind of small, but what you want to see is you want to see the general area. You want to see the rooftop of the far building that you're trying to get to. Look on other buildings around you. See what's cutting across you, okay? And try to get an idea of what it is. If you have it available, use a spectrum analyzer. Do your loss and distance calculations. Aeronet's website, www.aeronet.com, has a Microsoft spreadsheet up there that will allow you to do distance calculations. Punch in the radio types, punch in your signal losses or signal gains for the antenna, bit length of the cable, loss on the cable, etc., and then what bit rate you're going to push across it, and then it'll give you an acceptable distance with a 10 dBi drop built into it, which is usually pretty good to deal with rain and snow fade. Follow local code and ordinances. This is really important. In the county of Bernalillo in New Mexico, which Albuquerque is a city of, they recently enacted an emergency ordinance that is now freezing the building of all antenna towers. So basically what they're trying to prevent is the cell phone towers going up all over the place, and they're trying to get some sort of control to it, of how they're going to look aesthetically and so forth. But make sure you follow local code and ordinances. Make sure you know the terms, conditions, covenants, and so forth if you're trying to do something in a community area. a gated community, etc. The community of Tanawan, which sits inside of Albuquerque, does not allow anybody to put anything on their roof other than one of these little DirecTV satellite dish things. No ham radio antenna towers, nothing else. If it's not a DirecTV antenna dish or satellite dish, they don't want it up there. Also, from a business perspective, make sure you adjust your ISP terms and conditions and AUP policy documents to reflect that, hey, you're not responsible for weather issues. Lightning, wind, rain, snow, those kinds of things are going to potentially affect your network depending on how you have it engineered out. You want to put some sort of language in there that says you're not responsible if the network fades out a bit because you've got a torrential downpour happening. You're not responsible for interference. This is all public and unlicensed. Everyone has to accept everybody else's interference. And you want to make sure that you have some plan to deal with downlinks. The mean time between repair of a downlink can vary depending on what it is. Right now, I have a fight going on with another wireless provider in Albuquerque. They're using frequency hop. I'm using direct sequence. They're dumping all over me directly, beam right across my antenna. And we've got to figure out is how we put some separation on that. But that link is down at the moment. And thankfully, it's not a customer link. It's one of my own links, and I'm able to route traffic a little bit differently. Have spare parts. Do a test install. We do site surveys. And what a site survey really is our little site survey kit. This 4 to 6 foot, 1 1/4 inch or 2 inch pole. We put a 23 dBi grid dish on it, piece of coax, a radio, and a laptop, and we truck up on the roof. Plug into an AC power, stand there, look at the radio, pivot around until we get a beam pointing at one of our other antennas. If we can get a link, we can basically get a link up, then I get one person to hold it, and I go down on a laptop and I do a link test. And I try to push traffic across it and see what kind of performance I get across that link. Do that before you sign anything with a customer. Okay? Tell them that part of the install process or the sales process is that you want to come out there and do a site survey. So come out and pop up there and see if you can do it. Yes, that means that's some time on your end, that's some expense on your end because you have to take that time and do it. But it's a heck of a lot easier to go do a site survey, find out you can in fact get a link there, that the physics works, than to come out, put an install in, set it all up, turn it all on, and find out you can't get a link. Okay? Check quality. Note general heading. Note the elevation, whether or not you have to point the antenna up or down, as long with heading. Okay? And then once it works with a high gain antenna, try it with the antenna you plan to use at that install. Most important part of the installation I have found is the antenna. If the antenna is installed poorly or incorrectly, it will be the point of failure and the point of your greatest amount of frustration. Make sure the mount is strong. If you're anchoring it into a wall, make sure you're not anchoring it into a wall that's 2.5 inches thick of stucco, because stucco doesn't have a lot of load-bearing capability. You want to go into the cinder block behind it, or you want to go into the wood that's behind it. Or you don't want to drill into the stucco at all. Okay? Big thing. Make sure your wind loads are really high on an antenna. Make sure that thing is mounted and guy wired down. Even if it's a short little guy wire it out to the skid or guy wire it right around the building edge close to it. Make sure that when you look at the bricking that you have like a brick skirt around the top of the building. Make sure it's not just an aesthetic brick skirt. Make sure that brick skirt is really anchored as part of the building and can take a load. A 23 dBi grid dish antenna in a 50-mile-an-hour wind will be almost 200 pounds worth of load. Okay? Do basic high school physics, extend that up on a 30-foot mast, think about your lever arm. The thing will sit there and sway like this. And it'll do this hour after hour, and you have this nice low-frequency oscillation happening there. And pretty soon, if you don't have things guide, it's going to break. And what happens? Antenna goes off the side of the building, which is not good. Okay? Make sure it's happened. I've seen it. Make sure that your coax cable is tied down. Make sure you have lightning arresting equipment and that it's grounded. Don't just ground it to that breather pipe that happens to be on the top of the building. Make sure it's a real earth and ground. Again, use rubber mats to protect the roof. Keep your coax length short. Don't go and put 10 or 15 feet extra spool of coax there, because every foot of coax is signal loss. Okay? Keep it short. I like to keep it under 100 feet. I prefer to keep it at 50 or 60 feet. Most of the boxes you buy today, antenna comes in, Ethernet goes out. Well, extending the Ethernet part downstairs into the building or whatever is a heck of a lot easier than extending the coax, and a lot cheaper. Okay? We use fiber to extend the reach from the radio into the network. We use the fiber for two reasons. One, fiber has a great immunity to plant noise. Typically, we're putting a radio up in the elevator room or the HVAC room up on top of a building. There's a lot of electrical noise up there. So we use fiber to run down to the first service floor in the building, telco room, and then from there, maybe we'll run Cat 5 or what have. The other thing is that it's wonderful lightning protection. Okay, think about it for a second. Got an antenna, coax cable to the radio, lightning protection, radio, fiber to your catalyst switch or what have that's downstairs. If you get hit with lightning, it's going to probably take out the lightning arrestor. If it's a good bolt, it might blow the radio too. But what's the likelihood of that lightning propagating across the fiber? 0. Make sure you tape all the connections. You have a antenna cable connection, little pigtail comes off the antenna, you put it on your feed cable to the radio. Make sure you tape that up really good, because you don't want water and moisture getting in there and creating corrosion. Okay? I use a 3M weather tape. It's about 3 millimeters, 4 millimeters thick. It's really good stuff. Don't use electrical tape because it doesn't work. Don't use duct tape because it doesn't work. If you're going to use tie wraps, use black nylon tie wraps. Don't use the white tie wraps. The white tie wraps will blow apart in the UV. The black nylon tie wraps are UV protected. Okay? Place the coax in conduit. I don't know how well that shows up, but here's a 23 dBi grid on top of, I had to do this. Greg, please forgive me. This building in Albuquerque we call the Darth Vader building because it's jet black, okay? So on top of the Darth Vader building, we have our 23 dB grid. This is about a 6-foot, 7-foot pole, and then you can see down here at the bottom, you can see the skid. Notice if you look real carefully, you might see the other antenna. There's somebody else's antenna right here. And so we're above it, pointing out that way. Okay? This distance from here back to our journal center, for those of you that were at NANOG 12 at the Crown Plaza in Albuquerque, right across the street from there is the journal center where our data center is. Distance from this antenna back to that antenna is 6.5 miles. We run 5 megabits on that link. Here's another side picture of the antenna. Okay, small, lightweight, it's not a big radome. Here's some better pictures of antennas. This is a 23 dB grid. This is an 18 dB grid. This has about a 14-degree spread. This has about a 7.5-degree signal spread. Okay? Most property managers think those are ugly. Most property managers love these little guys. These are about anywhere from 11 to 16 dB gain panel mounts. And they're about probably 3 inches, 2 inches thick, 7 by 10 inch square. And you can just mount that right up on the side of a wall. Equipment costs, 1 to 2 megabits, you're looking at about $2,000 an end. 1 to 11 megabits is somewhere around $2,400 an end for the radio. Antennas, panel mounts are about $300. Grid dishes are $300 to $500. Those are the manufacturer retail prices. If you go to the antenna manufacturer directly, I can get this $500 grid dish for $92. Okay? So spend the time to hunt down sources for your products. Problems. Interference from other devices is the biggest. Weather, rain, snow, wind, thunderstorms. And sort of in tribute, though Stuart and I did not have any collusion on this, in New Mexico we have to also worry about Department of Energy labs doing something funky. They get their trestle going or something else, and poof, we can sometimes be off the air. But then they knock lots of things off the air. Wind, again, frequency congestion. The biggest thing I would recommend to people is if you're in a community and you're going to start doing a wireless deployment, go form some sort of organization, be it loose or formal, where you all sit down and figure out what you're going to do frequency-wise. If you're all going to use frequency hopping, great. If you're going to start mixing frequency hop and direct sequence, be careful about that and make sure you understand where it's going to be. Other things to try when troubleshooting: lower speeds, different frequency ranges, verify your physical connections, make sure the antennas didn't get blown over too. Lightning arresting equipment, know your environment. Our biggest problem in New Mexico is wind. Antennas get blown over or blown off, and so we've had to design some very interesting things to keep them anchored. Big thing from us, from a networking perspective, is remember that all of these devices are operating at the OSI layer 2. They are a bridge. Broadcast and multicast are going to propagate across the WAN network that you build out. Filtration tools are either very limited or extremely poor. I really wish the wireless guys would turn around and put stuff in. Other things, problems with interference is packet loss because of poor queue depth. Most of these radios do not have a deep packet queue. If they have to start doing lots of resends, you're going to blow the queue up, especially when you start pushing more than a meg or two across it. Biggest feedback: saves customers money. We like it because it increases our profitability, gives us better control. Potential markets, things to think about: office parks, residential communities, multi-tenant buildings, etc. Last, I want to say thank you to Lucy, Randy, and the whole team at Doing Merit. This has been one of the best NANOGs I've ever seen, especially with all the music going. I'm done.
Oh, thanks. We'll invite Eric back up, and maybe if there are any questions in the audience, if Stephen has any more microwave concerns or whatever.
Baby concerns?
Or what? Or baby concerns, yeah.
Hey, let's give Stephen baby advice.
So, any questions for the two? Go to the mic and just introduce yourself. We're trying to keep this sort of atmosphere of community, so we all know each other's name, and you know.
Hi, my name is Raymond. I work for Infonet. Just a question for, I think, Eric. Have you? I wonder if you see this type of wireless deployment, especially on the local loop side, being deployed in South America countries. Like Ecuador, Caracas,
yeah,
Guatemala, these places.
I don't see any reason outside of local frequency regulation as to why this technology couldn't be deployed down there.
Do you have?
I'm sure we do. I can't speak specifically to who is doing it. Again, if you'd like, I'll be happy to get that information for you. It shouldn't be that difficult. I mean, you know, we've got people all over the world deploying this stuff. But to get some specifics as to what's going on outside of the U.S., I would need to get someone from some of the international groups involved to get that information to you.
My second question would be: is that do you think it would be cost-effective to use this type of links as a backup to the landlines in very remote distances?
Oh, absolutely. Yeah, that's one of the primary applications we've seen. Wireless is not a replacement for wire-full applications or wired applications. It augments your capability there. It provides you with greater flexibility. It does not replace it, especially given the limited throughput that you can realize with wireless. It's a very specific. There are very specific applications where wireless really makes sense. On the other hand, there are applications where it just simply doesn't make sense, and where it's going to be a while before we get even anywhere near the kind of bandwidth that specific applications, that is computer or other applications, require. Not only that, but also where there may be some privacy issues, despite the fact that you've got strong encryption or what have you. If you're running a critical application and someone flips on their microwave, and there goes your bedside monitoring system. I mean, those sorts of things can detract from the use and acceptance of wireless. But in those instances where there are you can assume a reasonable amount of risk in deployment of those technologies, it makes great sense. Again, to speak to a case study, Vail Ski Resort in Colorado uses wireless for checking people in, and that way they can bypass the long ski lines. They go around with a PDA with a wireless adapter in it and a Zon and a card swiper, and swipe people's cards as they go by, check in, check out of the ski area. It now takes literally just seconds, if not minutes, instead of waiting for a great number of hours. You've seen when you return your rental car, some of the wireless applications there, that you can assume a particular amount of risk there. When it gets to bedside monitoring, when it comes to critical process control applications, it may not make sense, and therefore you need to use your you need to be judicious in deployment.
Thank you.
Just real quick, I know the Aeronet product and a couple of the other spread spectrum products are now also being widely deployed in Europe. So I would imagine that you'll start to see a lot of that hitting elsewhere. Central and South America has been doing a lot of stuff wireless.
Hi, Blake Willis, Case Internet. Have either of you seen any deployment of other wireless technologies, such as LMDS or IP over PCS?
Yet.
Okay.
What I've primarily seen has been a lot of CD/PD testing, but not much in terms of deployment. And again, I think CD/PD was somewhat limited in scope and bandwidth. I mean, it was great 5 years ago, but today it just doesn't seem to hold a lot of allure except for some low speed, low bandwidth applications.
Susan. So, yeah, I think we'll cut the questions here, but I think at least John